Hello and welcome back to Doz's Television Workshop. Bit of an emergency repair for Sue next door. This is her panel heater that sits on the wall of her treatment room, and this morning she sent me this video.
Andy, my heater's knackered, so I switch it on and that happens. I'm freezing and my patients are freezing and I don't have another heater.
So I've got it plugged in, and if I switch it on now, get my head out of the way, you can see it does flicker a bit, but it does seem to work. So what's going on here? I've got a sneaking suspicion we've got a capacitor that's not very happy when it's cold. Let's get into it. Right, so how to get into it? A lot of screws sort of around the perimeter. So I think we're going to be removing those. I haven't got a magnetic tray at the moment because we're still working on Matt's organ. It is coming. So let's just pull the plug as well. I'm not sure on a rating of this, so I don't want to plug it into the isolation transformer and overload it. What is it? Oh, 1500 watts. No, the isolation transformer is good to 1000, but that's it. Right, let's gently lift that up and see what we can see. Okay. Right, you're not going to be able to see that really. We've got the front control panel here. Can you see much? We've got a front control panel that is mounted to the front. We've got a power supply in the back here, which goes to some sort of modules there. I suspect they're thermostats of some description, or I bet they're microtemps. So that's on this top contact. You swing a camera around, see if we can see that. Yes, you can just sort of get in there and see this. So this top contact's ACL. Come out, come out. What else have we got to take out to get this out? We've got to get them all out. So that PTC1. I wonder if this is a PTC heater. It could well be, looking at it. I presumed it was just an element and a radiator, but it could be a PTC heater. Okay, so from the bottom we got PTC1, red wire, a white wire that says PTC2. Then we've got another red wire that is marked up with something. Let me unplug that. Right, that's the control, one of the control panel wires. The other one seems to go to a plastic sort of rivety thing on the back, which presumably is the temperature sort of sensor for the room. I think these in here, these will be microtemps or thermal fuses, if you like, just to pull things off in the event of an overheat situation. Right, so I try and get these crimps off of here, and I'm not having a lot of luck. I'm going to just pop this sensor out, then I can move the control panel completely out of the way. Oh, that's not helped. I left a screw in. That may well help. Ah, yes. Right. I've still got to undo some bits. So let's see if we can just get that temperature sensor out. So it's this thing here. I just need to squeeze it and pop it through, I think. Ah, I see, it rotates. Okay, so if I rotate it a few degrees, it should pop in. It's one of those things that's designed to be fitted, not so easy to remove. Gotcha. Okay, there you are. We've got some zip ties in the way, so we'll just cut those out for now. We'll replace them when we put it back together. Right, that's the control panel out of the way. Now we can see how things are. This is obviously a PTC heater. I think those are two thermal fuses. A little switch mode power supply converter in there. That's my suspicion. Yeah, right. AC 220, 240 volts, 1500 watts. Could be a conventional heater, not sure. Anyway, next trick is to try and remove these spades so we can get the power supply out. Gah! Tell you what, it's a good connector. I don't know what you say about it. It does not wish to come undone. I'm not gonna do it with that one. I'm just gonna cut away some of that heat shrink so I can actually see what sort of thing it is. Except for all my scalpels have disappeared under the generators. There we are. That's what I want. Got it. There's that little pair of pliers. Yep, there's a locking pin just there. Easy when you know how. That's PTC1, and that's going, unsurprisingly, to the heating element, which is obviously a PTC. PTC's positive temperature coefficient. So the idea is it sort of regulates itself. Here is the second one. Why don't you just, yep, there we go. That is PTC2 in white. AC in. Goes to the switch, unsurprisingly. Gotcha. COM. That's our neutral. Gotcha. And this one is marked ACL. Gotcha. Right, we are disconnected. There was a ribbon that went in there. Went off to the control panel, obviously to control these two relays, which switches our load, which would seem reasonable. One thing I'm going to do, I'm just going to hoover the dust out of there. All heaters end up with dust in them in the end. You know, they're drawing heat through them, so yeah. So there we are. Right, out with the control panel. You can put the heater itself to one side then and get on with what I think is the problem here. There's 4 smaller screws holding it in a very nice sort of plastic enclosure. There is some protection, as you can see, because the heating element is here, so it's sort of going to deflect the heat round it to try and give it some life. They've thought about it a little bit, haven't they? Which is nice. Right, let's take this out and inspect it. Let's put the heater itself to one side. Ooh! Epic. Right. So, let's zoom in a little bit so you can see. Look at that, perfect. Right, so we've got some sort of switching power supply, I would imagine, to supply the low voltage logic. So what have we got? We don't appear to have a transformer, do we? So perhaps it's just a sort of buck converter straight off the mains. We have got a 5-legged device, 4 on this side, sorry, 7-legged device, let's get that right, 4 on this side and 3 on this side with the usual missing pin. It is a PN8024R. No idea. It'll be some sort of switch mode controller. Should we have a quick Google? So Google's provided us with a data sheet. There it is, PN8024R. There's our little 7-pin package. And it's given us a little block diagram. So we've got mains being half-wave rectified here. We've got a CLC filter. And that is, interestingly, switching against ground. Our voltage is then developed across this inductor and filtered by this capacitor. There's a compensation network here. And these capacitors, really, I think, are the ones we're interested in. Okay, so it is a little switching IC. Takes in half rectified mains. It's only a sort of buck converter, so we've got a small inductor there, 1.6 millihenries, and well, big inductor, I suppose. This will probably be our secondary capacitor, and it's these I'm worried about. I'm not quite sure what that one is yet. There's supposed to be a bit of power supply filtration in here. I mean, there's some C's. I wonder what that is. That's bound to be it, I think. Yes, because we're coming off the mains sort of smoothing capacitors here. It's only half wave. We're not using much current, is it? So there we go. And they've thoughtfully written the part numbers. Look on the board. BYV26C diode. Lovely. Okay, so I think this is a job for my new capacitor measuring tool, which I've got from Peak Electronics. So here, by way of a bit of an unboxing, and here it is, the new Atlas ESR70 Gold. Yeah, I've been promising myself for a while, and I sold some projects that we'd completed on eBay, so plough the money back in. Now I've also bought some extra probes. I thought these were included when I ordered it, but they're not. These are the sort of stabby needle probes that are very good. So these are extra. If you go and order one, you'll need to order these as well, unless you just want to live with the clips there. So it's got automatic discharge function. I think it's limited to 50 volts. We'll just see how zappy that is in a minute. But yeah, how do we get into this, man? I say it every time, don't I? How much of my life have I wasted opening packets? Here we go. We're in. Hurrah. There we are. Super stabby probes. Oh, yeah. Look at those. Look how sharp. Where are we there? Look how sharp that is. Lovely. Yeah, they come with a little protective thing on them, which of course I shall instantly lose and spend the rest of my existence stabbing myself with it. It's only a bit of tube, actually. That's quite neat. So I'm taking it that these 4mm things undo from there. Brilliant. And go in there. Yeah, look at that. Fabulous. So, because we never do until we get stuck, let's just switch it on. I'm going to dim the light down a bit so we get some idea. You'll be able to see the display a bit, but actually you can't, can you? There we go. Anyway, it's monitoring for component. Let's do that again. It is a P Catalyst ESR. Oh, give me time. Model ESR70G version 6. Presuming that's a firmware version. Right. So it says it will work with it with the components in situ. Now we can take that with a pinch of salt. I used to have a meter, most excellent, had the same sharp needle probes, called a capacitor wizard. Unfortunately, that's gone over the years. No idea where. But let's just have a look around here and see what we've got. So I'm going to need to open those up a bit. There we go. So that's that very little one on the analyzing we're in. ESR greater than 40 ohms, capacitance not measured. Wow. Okay, ESR greater than 40 ohms. Pop the iron on. Let's just get that out. I'm just going to take a quick note on the board. Turn the light back up again. I'm altering the colour temperature rather than the brightness. I didn't know I had colour temperature on there. Cool. Right, it is earthy side this side. It is actually marked with a shaded bit on there. Interestingly, the legend on the board has a position for two of them. You can see there, both 10 mic 50 volt. Maybe they've put a 22 in there because they're both, oh no, they're not in parallel. Yeah, as usual, somebody somewhere has cheapened the design. Oh, come on out. Ah, interesting. Yes, our meter has just switched itself off. I do like Peak kit. By the way, I am not affiliated with Peak other than a delighted customer and user of their kit now for many years. You've seen the DCR on here before. Digital component analyzing thing. I'd like a new one of those really, because they've updated that now. I can just tell you that this capacitor stinks. That is unpleasant. When I've desoldered that, it smells horrible. Never a good sign with a capacitor. Right, pop that on again, get on these leads and see where we get. ESR greater than 40 ohms, capacitance not measured. Rest in peace, my friend. Right, so he's probably just doing enough when it's warm and not doing enough when it's cold in the morning. The heater goes to come on and it's just sitting there flashing its display. Right, it is 10 mic at 50 volts. We shall want a box of capacitors. Interesting. Look at the size of my not very old 10 mic at 50 volts. And look at the size of that one. So there's the new one. And there's the old one. Okay, so this is 10 mic at 63 volts. We're in the same ballpark, look, but look at the size difference there. Makes me suspicious. I think that capacitor is probably something nasty and cheap. If it ever managed to make 10 microfarads at the start, I don't think it probably did. Right, let's get some desoldering braid. And once again, you're going to watch me change a capacitor. Won't take exactly very long. Right, holes are clear. We knew that the shaded side of the thing was negative. Can't see me on camera, can you? Because I've gone too far away. There we go. Pop that in there. Splay the legs apart a bit so it stays put. Yes, that nasty sort of odour of... Oh, I don't know what it smells like. It's like a sort of fishy smell. Which means we've been leaking electrolyte from somewhere, usually. Not always. Sometimes you just get a sort of smell from a PCB. But no, I don't like that one. It's coming out. Certainly with an ESR bigger than 40 ohms, it's just ridiculous. Let's just see what the new one measures like, as by way of comparison. So, and it's in circuit. It's analysing 9.58 microfarads and 1.06 ohms. That's a bit of a difference, isn't it? Right, what else have we got in here? These are the high voltage smoothers. I wonder how zappy they are. Let us just... So what's the rating on those? We've got 450 volts, and they are both 4.7 microfarads. Not quite in parallel, but look at that. I'd expected them to be. Ah, they've got the choke in the middle of them, which is fair enough. So let me just see if there's anything zappy stored in there. No, and unsurprisingly, no. Right, good. I don't want to blow my new instrument up. Right, test. Analysing, waiting. Oh, circuit low capacitance. Yes, all right, fair enough. Right. Go. Analysing. In circuit or leaky? Fair enough, it is in circuit. In circuit or leaky. At least it's telling me that all is not well and we're going to have to remove them, rather than it just relying on my better judgment. The capacitor wizard, in fact I've seen it recently online, the capacitor wizard. It was an American instrument, and I think it was sold under a different brand. I think it was a capacitor wizard in the States. I'll see if I can find a picture of it and insert it here when I just get these out. And I think it was sold as something else as well, so you may recognise it. I remember it being a very expensive instrument at the time. But it was very good. Right, both grounds are pointing towards the relays. That's horrible. Let's leave that out of the way. Do you get the feeling my bench is starting to move this way a bit? That's better. Oh, analyzer's put itself to sleep. I like the way I just went from one capacitor to the other, and it knew I'd taken my probes off, and it reset itself and then had another measure. I'm quite impressed by that. Peak, you've done the job again. Right, okay. I suspect these may be okay. Right, on monitoring for component, okay. How about that? Analysing 4.24 mics, 15 ohms. Are we happy with that? Don't know as we are. What have we got here? That one's even worse at 16 ohms. Let's measure a new one, if I've got such a thing. Higher voltage stuff is in here. The beauty of this enclosure, of course, is I've got quite a lot of space. Have I got anything 4.70? I have. What are those? 4.7 at 350, and these are 4.7 at 450. 350 isn't quite enough. Okay, what else have we got? 4.7 at 450. So let's see how that one measures. .3 ohms. What do we have here? 20 ohms. Yeah, I think we'll treat ourselves to some new ones. have I got two of a similar vein? 4.7, 450. This is a little bit more modern, and I've just dropped one actually. Where did that go? Was that one of our old ones? Ah, that was one of our old ones. You can imagine these capacitors, I mean, even with that shield round to direct the air round, you can imagine them having quite a hard life. Right, what have we got here? 3.3 ohms. Let's put two new ones in. The biggest problem I'm going to have here is space this way. That one is certainly a 105-degree component. That's a point. Yeah, these are allegedly rated to 150 ohms. What about this one? Yeah, they're both 150 degrees, so that's something. This one's been tacked in somewhere, isn't it? I bet that was on a valve amp as I was proving a point. Okay, so was this side or negative was this side? I'm gonna have to cut that back. I do like the twittering noises it makes as well. So very nice. Not a very pleasant job, but it is what it is. Susie does need to keep her patients warm tomorrow. Right, onward and upward. That one was faulty. These two are faulty. It doesn't bode well, does it, for the rest, really? I suspect this one is the secondary. No sign of any electrolyte leak. Sorry, it's a 470 mic at 25 volts. Yeah, I should have tested it in circuit. Especially as most of the secondary is disconnected. Star. What does that mean? Are we charged up? Let's do that again. So, 350 mic is supposed to be 470. An ESR of 1.05 ohms. I don't know what that star means. When all else fails, read the manual. Fetching shade of pink. That's not a colour temperature issue. So, yeah. Okay, perhaps it's just letting us know it's a big one. Okay. So what was it? 47 mic at 25 volt. So put the high voltage parts back away for a moment. 470 or 47? 470, wasn't it? 470 mic, 25 volts. 470 mic. Blimey. Some super looking things in here. A 680. He's gone over the road a bit. Okay, I get very low on 470 mic parts. 470 mic, 25 volt. I bought these special for a job. I had to buy several because they're long and thin and slender. Look, like I say, we're not stuck for a part. 0.03 of an ohm. So yeah, all right. I think we'll have him out and get him changed. There's the asterisk again. I wonder what else it'll tell us. No, okay. It doesn't tell us anymore. Peak, if you're watching, what does that asterisk mean? My holes are blocked. Where are they? There they are. Okay. So, again, we're not short of space inside this enclosure. You can see why maybe they did that, though. I suppose if they're building a very, very slim heater, they could have run into trouble. Right, that's fitted in. Let's just solder it up. I think we've got one left, haven't we? Yep. This one over here, 220 mic at 16 volts, follows a 5 volt regulator, 78L05. So he's obviously just decoupled a 5 volt regulator. 220 mic at 16, 220 mic at 16. Well, good with the markings on the board this time anyway. I didn't measure it in circuit again. You see, I've got out of this habit. Right, what have we got? .81 of an ohm, 184 mic. Look, I'm in there, I'm not going to leave it. We shall have a new one. I suspect that one is perfect. It's a little bit low in capacitance, and the ESR has crept up slightly at 220 mic, 16 volts. Let us just pop the peak ESR on there. Ohm circuit, low capacitance. That's a bit of a worry. It's brand fire new. No, we're good. 0.25 an ohm, but it's better in capacitance. Right, we'll have that in there. So, let's face it, it would have been quicker for me to just go in here and change all the parts rather than measuring them. Maybe. But it's it's a good demonstration of the ESR meter there. So, and it beats my old one, which is the Sega one, which never measured anything in circuit, never gave me any of these lovely warnings. It didn't measure capacitance, it was purely ESR, but it did, it's done me proud, and it wasn't a lot of money when I bought it. I don't think it was £20. So I've had my money's worth out of it over the years. There we go. That's not very neat, is it? If I was not in such a hurry to get Susie's treatment room fixed, we'd get the right things for that. But it's not going to go anywhere, is it? So we shall pass this off as I'm happy with it. Okay, next thing, have a little clear up and get it all back together. Right. I've got the rear back together. This is the front panel with a control panel on it. And I'm just thinking, well, while we've got it apart, best we check in here. Especially as I'm just looking through this sort of slot in the top here, and I can see one of the plastic pillars is very distressed. And I'm wondering if this is, because you can see, you see that on the top camera? Just turn the lighting a bit. Yeah, you sort of get the gist there. You can see this sort of smutty mark, and that's where the heat shield is trying to keep the electrical side of the appliance cool, and this is where the dust is being drawn in. And any heater will sort of do this, and it sort of stains it. It's just convection, and it sucks in the dust from around it. But yeah, right, let's take it apart and see if we've got any electrolytics. Because what does bother me is this sort of, if you think about it, the plastic box that holds the power supply is here, but there's no real sort of section there. So maybe we have some cooked electrolytics in here as well. Yeah, this one, that screw is just spinning. What we don't want is this metal box falling apart, the control panel falling out, because bearing in mind that voltage in there is reference to mains for a start. Two, this metal box may fall down into the main switch and the rest of it and go short something out, go bang and ruin your day. Right, what have we got? We've got bits of plastic. Oh dear. We should be able to do something with that. Yeah, they've either forced screws that are too big into the holes, or the plastic's becoming brittle with the heat. That looks to me to be a memory battery. It's got a clock and a timer in it, so that wouldn't surprise me. We've got a black blob with lots of legs on it, which is going to be our microcontroller. And if I could find my loop, we'd have a look to see what it is, see if we recognise it. Use this one. It is a brand I don't recognise. There's a surprise. It's a KM something or other. Yeah, there we go. It's a microcontroller. It's controlling the front display and touch sensitive push buttons, etc. Right, 4 screws, dare I? Let's just move these out of the way. Are these, you see these are all split as well. I'm inclined not to. I think we'll just run, oh, there are 2 electrolytics there though. What's that? 100 microfarads at 16 volts. Right, let's have a look, see what it reads like. So let's put that on. So it's on these 2 pins on the end here. There's another one over here laying that way, so whoops, yeah, let's go again. 4.9 ohms, that's not very impressive. 5.3 ohms, they're both down on capacitance as well, which probably means that just the ESR has risen and it's struggling. So what does it reckon? 100 mic. We've got a chart in here, so we've got 100 mic. How many volts? 16, wasn't it? $16 volts, 100 mic, 16 volts. It should be about 2 ohms. Well, we've got double that. Just because I'm here and it's easier for me to do them, let's get them out and get them changed. Oh, that wasn't the struggle I thought it was going to be. We'll just have a quick look at this temperature sensor while we're here. What's the betting? Yeah, look at that. That'll be a bead thermistor in there. And the microcontroller will just be passing a small current through it and measuring its resistance. And having a best guess at the temperature. Surprisingly accurate, actually. Certainly when I've played with them in the ping pong clock project. If you go on my website back then, you'd have known about that. Right, what am I going to do with these standoffs? I think we're going to put a zip tie around them and just run some of that thick black super glue into it. Just to give it some strength. Right. That'll stop the situation worsening. This one might be a little bit more difficult. Ooh. That's going to stop any of that moving around. This thick black super glue, by the way, it just has some sort of, it's a lot thicker than conventional. It has some sort of gap filling properties that the ordinary clear stuff, which is of course really quite, what's the opposite of viscous? Very runny. Yeah, this has a bit more to it. I'm going to go very gently with these. The glue should sort of set them in place anyway. That has got some grip on it now, so that pleases me. That's good. Right, let's button both halves back together. Excellent. Right, I'm now just going to plug it in, I suppose. That's very interesting. I don't know whether you can see that from the camera, but the crystal now is very much clearer, and yeah, it's not flickering at all, which obviously it was on Susie's video, and there was a bit here, and that the LCD crystal didn't seem to be to have any contrast to it. So yeah, I'm calling that a win. Is it heating? Oh, it is. Yep, we've got some heat going on. Fantastic. For future reference, it's a porous digital panel heater. Much better than those old-fashioned analog ones. So there we go. If you ever got one of those with a flickering display and won't work when it's cold, now you know how to fix it. The porous digital panel heater now working perfectly, and of course repaired using the Peak Atlas ESR70 Gold ESR meter. I'm going to get a lot of enjoyment out of that. Sad, isn't it? But there we are. Thanks for watching. Do like, subscribe and all that stuff, and pop back along soon to Doz's Television Workshop. Cheerio. That's it. Oh, my arm's getting hot. Digital panel heater, and of course the leak. It's a peak. Let's do that again. One more time. Peak. One last time. I've got to turn this down a bit. I need to finish this blooming video now because my arm's getting really hot. That'll leak. Stop.